Okay, 2.7 is perimeters and areas of similar figures. Remember, similar figures are made by enlarging or reducing, so dilations. So let's get started. Okay, so rule one here, key idea one, is that the perimeters of similar figures, that when two figures are similar, the value of the ratio of their perimeter is equal to the value of the ratio of just one side, the corresponding side lengths. So all that's saying is if we know the ratio of this to this, which would be corresponding sides, then we know the ratio of their overall perimeter. Okay, and they're the same. So that's why they have the perimeters here set up to the any of the three sides that match, but the one I underlined is the one that I have over here in yellow. So you could just set the perimeters equal to the side lengths as a proportion and then cross multiply. So if you look over here, you can see that we're going to set this up as the perimeter. The red rectangle is going to be on top, blue rectangle is going to be on bottom, and you just set it up. Well, 4 to 6 is equal to 2/3. That's just simplifying. So the value of the ratio of the perimeter is also 2/3. If we knew the perimeter of one of them, then we could find the perimeter of the other. And we'll do that in a second. Now, area is a little bit different. So area is equal to, so again, let's go back to our yellow. So the area of the two triangles can be set equal to any side. So AB and side DE are the corresponding sides squared. Okay, so we square that. The way to remember that is areas are always in units squared. Volumes would be cubed. So just we don't do that in this, but just so you know. Okay, and so as you can see down here in their example, they took the area of the red triangle and set it equal to this ratio of 6 to 10. 6 for the red triangle, blue. It's going to be important to keep these in line. So red and blue, and then they square it. Well, when you square, well, first they simplified 6 over 10 and made it 3/5 to make the squaring easier, so that was definitely smart. So they divided both these by 2 to simplify to 3/5, and then they squared it. 3 squared is 9, 5 squared is 25. Therefore, the value of the ratio of the areas is 9 over 25 in simplest form. So just like fractions, they're going to want these in simplest form. Okay, so let's do area and let's do the area and the perimeter. Okay, so first thing we're going to do is set up the perimeter equation. Okay, so basically what it's saying is a swimming pool is similar in shape to a volleyball court. So we have our pool and we have our volleyball court. Okay, so we're going to find the perimeter and area of the pool. Okay, so they've given us the perimeter and area of the volleyball court, and we're going to use that. We're going to use that to set up a proportion, okay? But first, we need to understand and remember the difference between the ratios. So the ratios of a perimeter and the ratios of an area. So the perimeter ratios. So let's right over here. Let's look at that first. So the perimeter. I know I'm confusing this. So let's just call this PER. The perimeter ratio to pool to volleyball is 18 to 10. Which simplifies to, divided, 2, so that'd be 9 to 5, okay? So the perimeter is 9 to 5, and the area, so this is the ratio of the perimeters and the ratio of the sides, right? And then remember, our area is simply the square of that. So the ratio of the areas is that squared, which is 81 over 25. We square the top, we square the bottom number, and that's how we get that. Okay, so knowing that, we're going to again use the given perimeters of the volleyball court to determine the pool. So let's set this up. So pool to volleyball is what we're going to do. So we're going to work on the perimeter first. Let's draw a line here just so we kind of keep everything separate. So the pool's perimeter is unknown, also known as X. The volleyball is perimeter is 60. I got that right here, 60. Okay, and then now I'm doing perimeter, so I'm going to use my 9 to 5 ratio. Now I multiply across, and I get 5x, and 9 times 60 would be 540, and I divide both sides by 5. And I get x is equal to 18. So the perimeter of the volleyball, let's see if I did that right. 9 times 60 is 540. 540 divided by 5 is 108. Sorry, I forgot my 0 in my head. That's why you don't do it in your head, do it off to the side. So it equals 108. And the reason I did that is because it made no sense for me to have a perimeter of 60 on this smaller thing and a smaller perimeter up on the pool. So it helps to always be expecting a certain number. Like that saved me right there because I tried to do something in my head. That's another reason why we shouldn't do that. Okay, so now we're going to draw another line, and we're going to figure out the area. So again, pool to volleyball. Again, we don't know the pool's area, so that's unknown, but we do know the volleyball's area is 200, and our ratio for pool to volleyball in area is this 81 to 25. And now I'm going to use my calculator on the side here, so we're going to cross multiply. 81 times 200 is 1620, 16,200. Sorry, I misspoke again. And 25 times x is 25x. Divide both sides by 25 so I can get x by itself. And I'm doing this on my calculator, is equal to 648. And let's make sure. So this is yards and this is square yards. We write square yards like that. Okay. Does that make sense? Yes and yes. So those will be my final answer, and we will be correct. So if you have any questions, before I go to that, I just want you guys to understand that the main point of this section is understanding, let me get my little laser, this relationship between the perimeter and the area, okay? The whole point of this. So what it's saying is the ratio of the sides of two similar shapes, okay, is this 9 to 5. So if you have two sides and you know they are similar shapes are shapes that have been dilated, okay? So they have been reduced by a certain multiple whether that would, they've either been reduced or made larger, right? So we've already learned that in this chapter by a specific factor. If you have similar figures, okay, then the ratio of the sides is the ratio of the perimeters, okay? So if the ratio of this side and this side is 9 to 5, the ratio of this side and this side is also 9 to 5. And so if this ratio and this if these ratios and these ratios are both 9 to 5, that means this one is and this one is. So that means all the way around the ratio is 9 to 5. So if you add up these ratios, the perimeter stays at a 9 to 5 ratio. Okay? Now when you're talking about squaring it, you're talking about in a rectangle is an easy one to understand. You're talking about length times width, right? So yards times yards. It's a square relationship. So you have this 9:5 ratio times this 9:5 ratio. So you end up with 9 times 9 over 5 times 5, and you end up with this square relationship, okay? This also holds true with circles. It also holds true with hexagons, with any of the other shapes, two-dimensional shapes. Their ratios do hold. But just remember, the perimeter has this single 9:5, but we have to square it for the area. And look at our units; it makes sense because you had yards here all the way around the perimeter, so each side stayed yards and stayed 9:5. But when we did the square, that became what our area is, or our ratio is for the area. So the main point is the ratio of the perimeter is the simplified ratio of the corresponding sides of the similar shape, okay? And that holds true all the way around the perimeter. So this side and this side would also have the same ratio, and that's true for the whole perimeter. But for the area, it is the square of that perimeter, okay? And then we can use these ratios, okay? We can use these ratios to find the perimeter and area of the similar shape if we know one or the other, like we did here. Okay, so hopefully that makes sense. Work hard. One other comparison I want to make also is, and this is kind of important. So the perimeter was 9:5, right? So if I take 9 divided by 5, I get 1.8. So we could say that the perimeter is this is 1.8 times larger than the volleyball court. Okay, but when we look at the area, look what happens. We have 81 over 25, and there's a circle question that you'll need to know this on. So if we take 81 divided by 25, we don't have 1.8, we have 3.24. So the area, this was the perimeter, the area is 3.24 times bigger. So the volleyball court, so the pool is 1.8 times bigger around, but it's 3 over 3 times bigger as far as the area, or where the water, the top, I should say, the layer of the water, the top layer of the water goes. So anyway, all right, well, hopefully all that makes sense. I'm sure you'll have questions. Come see me, or rewatch this part. This is probably the most important slide, and that you can always rewind and just listen to that last part. But understanding this relationship here is also important. So there you go. Talk to y'all later.